Okay, well, we're going to get started. Again, thank you for coming here today. By the way, I am cool, as is Clark. We want to make this interactive, so if you got a question and want to call BS or whatever, I'm happy to do it anyway. So let's get started. The beginning of this stuff isn't going to be unknown to you guys, but I mean, basically, the big data stuff is really becoming a big problem for enterprises. And for a lot of different reasons. It's stored all over the place in very complex and old structures. We recently saw a company the other day that their main operational system was a COBOL system. So I mean, it's stored in all kinds of crazy things. In addition to that, getting to insight is really, really hard. I know, for example, that Procter & Gamble has 4,200 business analysts. And what they are charged to do is going out and pulling data from all the disparate databases together, throwing it in some Excel or in some Microsoft Access, doing their magic and coming back with insight. It takes hours and hours and months and so on to do. And so what's happening now in today's world is it's dynamic. You need insights very, very quickly. So as I like to look at it, this is real. The struggle is real. In addition, we have this whole emergence of data science. Data scientists in your company. How many of you have someone with a title data scientist in your company? Yes. This really didn't exist, what, 5 years ago? Supposedly, people are telling me it's the fastest growing title now in corporate America right now. And they're very, very, very much in demand. And so what's happening is data scientists need to get to their data very quickly, but they're spending 85 to 90% of their time data wrangling. And as we look at it, I mean, this is kind of like the stage all these folks go through. I was mentioning the 4,200 people at Procter & Gamble. They go out, they wrangle the data, then they figure out how to clean it, then they analyze it any way they can through Excel or Python or R or whatever they happen to have. Then they create some visualizations. They have an insight. And then the CEO comes in, or the CFO, or the chief marketing officer comes in and says, wow, that's really cool. Could we add this piece of data over here? Oh, could we do this over here and add this over there? And all of a sudden, the guy goes, holy crap, I got to spend the next 2 weeks doing the same thing all over again. And, you know, we just see that over and over and over again. I have some great pictures. I was at a customer for FactGem the other day. And literally, they have 3 floors of people in these rows and rows of cubes, so I goes to the Pentagon. And what they all are doing, they all have Excel open. And all they're doing is querying their Hadoop warehouse, their enterprise data warehouse, their application, their POS database, whatever it happens to be, and doing that. And I call them, you know, graph cubes. Because what they're doing is each one is responsible for a single page in a report, a graph in one form or another. And this is how we've tried to fix this problem. It hasn't worked. So I'm going to have Clark kind of go through the next 2 kind of relationship 101.
Right. Thanks, Mark. I mean, it's funny, right? When I talk to people about graph and how you can bring your data together to solve these complex problems, and you know what I hear all the time? Well, I can do that now. I have Teradata, and I say, well, why haven't you done it? And then they're like, why? Because they know why they haven't done it. Because it doesn't work. The great irony, I would like to say, of relational databases is they're awful at relationships. Who would have thought, right? And that's the problem. All data is related. It's almost that the relationships matter, and relational databases don't get you there. After about 3 joins, you're dead in the water. You can't get there in a reasonable period of time. At HDFS, Hadoop, it's a cool technology. Hadoop data lakes are a big thing. It's a great storage platform. It's not a database. It's not an accessible analytic tool. You have to have smart engineers writing complex Java or other programs in other languages to do transformations, to get insight out of that. That doesn't scale for companies. That's too expensive. It takes too long. So why do it with Neo4j? Why not do it with something else? RDF, right? Everyone's been talking about RDF for what, 15 years now. Every couple years something new comes out. Oh, it's going to be RDFA. RDFA is going to solve everything. And it's going to finally be the semantic web. Yeah, it's never happened, right? It's not going to happen. RDF doesn't work. It doesn't scale. It's too hard. It's a non-properties-based graph. They don't scale. Sparkle is ungodly hard, too, right? I mean, who here tried to do Sparkle, right? Would you rather do Cypher? Of course you would. You can think about Cypher. and other technologies that are out there, they apply a thin veneer of graph on top of something else, right? On top of Cal, on top of HBase, on top of Cassandra, on top of an RDBMS. You're just putting lipstick on the pig. It's not going to help. Just saying I have a graph layer on top of an RDBMS doesn't get me scalability. It doesn't get me relationships. Only Neo really has that pure properties-based graph mark that lets you solve these problems today.
So what's going on in businesses today, and we've talked to a lot of this, every business has unique data. We all know that. That's not rare. But actually, I was in London last week talking to a whole bunch of customers, and I was going through their IT departments. And every one of the IT departments had this big piece of graph paper that kind of showed the connections of, okay, I got Salesforce connected to my Oracle database, connected to my POS database, and it's connected to this ETL layer, to this BI tool. And, I mean, it literally looks like, I don't even know what, I mean, it's such a spaghetti. And so we built this whole layer, and this is how all these corporations are running, okay? And this is and if you want to add new data to it, it's very, very difficult. And so the challenges of a Fortune 500 company now are very, very different. Because most of these companies have been around for tens of years. If you've been around for tens of years, you have some very important applications that are sitting in all kinds of different databases. Whether it's a Oracle database, a MySQL database, some of them, like I said, a COBOL, an old COBOL flat file database. It's all over the place. So what they do is they basically have it everywhere, and they have it in all these different places. This is an example of one of FactGem's customers where they had it in about 8 different places. But what they really wanted to do is bring all this information together very quickly and very rapidly. But the only problem is the only way they were able to do it is the way I described before. And the main reason why you can't do that, and we all know this, is, as I said in my talk earlier, I mean, SQL is not great at these relationships. Basically, once you go more than 3 joins, life gets to be very difficult and very unmanageable. And so the way people have solved it, as I've said, is they basically solved it with time, people, hardware, and other things. And so I can't tell you how many companies. I was at a large insurance company in Columbus just a couple weeks ago. They have 600 people, again, doing this business analyst stuff. You go to most companies, the way they have solved this problem is basically taking all this data, taking a whole bunch of people, and going all the way through it. That's how the process has worked. And so basically that requires more people, more hardware, and it starts adding up and adding up and adding up. And more importantly, it takes a lot of money. And so what we're finding is these, I mean, we have one group I've seen has 900 people in their IT department. Over half of them are just picking up the phone and it's the CMO going, hey, I need you to connect this data to that data. I'm trying to find this kid. That'll be 10 days and I'll get back to you. And it's just not how a scalable modern enterprise should be worked. And last but not least, if you want to add something new, as I mentioned before, forget it. Okay? You cannot do it. So when we were looking at at FactGem, a lot of people have a lot of resources to go do all this stuff, but they really hit a wall. And the wall is you can only take this so far. You can only, I mean, talking about 4,200 people, we've seen people 400 people, 600. It only can be scaled so far. The other thing is a lot of people try to solve this with Teradata, right? And all of a sudden you buy more and more and more and more and more Teradata. And there comes a time where that doesn't even scale because you cannot do all those joins together. So what we try to do at FactGem is we really fundamentally believe in the graph and combining all of this information together in a data fabric. And the core part of this data fabric is something that I think, whether it's a solution done by FactGem or you just put it on Neo or some sort of graph structure, it doesn't matter. The fact is, the matter is, you've got to link all this stuff together in your legacy enterprise, and you got to do it in very, very, very quickly. So, as you all know, this data is stored in multiple different forms across the enterprise. And so what we have seen is, some of these applications have, 400 entities, 200 entities, 100, whatever it happens to be. Each one of those things can be represented as a node. And so what you do, and we have done very effectively, is I think the fabric, you don't want all the data in each one of these databases. Sometimes you don't, maybe you only need the first name and the last name and their address. You don't need every single piece of data. That's the other fallacy that people have come across is they think they need everything and combine everything together. You don't. What you need to do is find out what the particular parts of data are that you need for each one of these different databases. Okay? And you pick which column, which node, which element you need, and then basically put them all together. Now, one of the things that I have found in the graph world is that you have to think about it differently. I was a programmer a long, long time ago. I was a 6502 8-bit assembler programmer. Not too much need for us anymore. But that was my Apple days. But you thought about things in a very structured, kind of two-dimensional way. In graph, you have to kind of think differently. So you have to be in a situation where you have to constantly be changing your ideas and changing how you put things together. And so one thing that we've done at FactGem, and I'll have Clark go through this, is really talk about what you want to be able to do is try new graphs, try new models, try things in real time so that you can actually apply things very effectively.
Yeah, right. And I think we've all seen it, right? We go out and we talk to even potential customers or within our own enterprise and talk to people about why we want to use Neo4j, how we can harness the power of the graph. One of the big things you come up against, right, is people don't know graph, right? There's 1,300 people here today, that's awesome. But for the most part, there's not yet a tremendous amount of expertise out there just in the wild on Neo4j and for graph. And we believe fundamentally that graph is so important. We want to make sure everybody can start to see the power of the graph because we think once you show somebody what you can do in a graph very quickly and you let them see insights that they could never see before because the data wasn't connected and they couldn't get those insights, then they're interested. Then they want more and they'll put resources and investments into giving people training and making investments in the graph to move in that direction. But you have to overcome that challenge and that's what we are really trying to help people do. We built a platform that lets you start on Neo4j immediately, taking your company's data, taking your customer's data, getting it loaded into Neo, build an application. We put a model on top of Neo, we put a schema on top of Neo, as Emma referenced today, I thought it was great. Right? No SQL doesn't mean you don't have a schema, it means you don't have to have a schema. The database doesn't enforce one, but if you're going to write an application, you kind of have to know what's your database, right? No matter what it is or what are you going to do? So we let you essentially draw it like you would on the whiteboard, have a schema, load the data up immediately, show the value of the graph, build a dashboard by dragging the graphics and things. Because now people start to see, they can query 6, 7, 8, 9 degrees down in the graph and see things they couldn't see before. And maybe see a chart or see some connections, some insight. Again, for a retail customer of ours, we did this big demo for them. And we had noticed when we were prepping for the demo that some people were occasionally going in and they were actually returning items, just returning items, and they got a free gift. And we talked to the COO about it. We told them this is what's happening. That's impossible. You can't do that. So we brought up the graph and we showed them. Look, here's the customer. Here's the purchase they made. Here's what was in the purchase. Here's the cost. And then you gave them a free gift. The guy lost his mind. Right? They were not happy, right? But then they're hooked, right? You can see the power of the graph. Once it's easy, you can see it. And you can leverage in your enterprise the power of a NoSQL, a NoSchema database with the support and the regulation and the comfort you get from having a schema on top of it so you can actually understand your data and manage your enterprise better.
So, I mean, the key thing I've seen out there is that with all new technologies, people just don't believe them. Oh, they're great, we can do this, we can do that, and some guy goes behind a curtain somewhere and they come back with something. They just don't believe it. And so what we have found when we sit down with folks is, Clark kind of thinks I'm crazy sometimes, but I've literally gone to customers and said, okay, we'll walk into your office, you give us the data from as many databases as you want, the highest level's been 15. You give us from as many databases in under 2 hours, we'll build the model, we'll load all the data, and we'll show insight to you in under 2 hours. The one we have with 15 databases, Clark was able to do in 41 minutes. So from now on, I'm doing under an hour. No. So the key thing here is literally, if you can whiteboard it, you should be able to load it, right? So literally, the best thing I like to do when I'm thinking about a graph, again, is just go up on a whiteboard and say, okay, I got a customer. The customer buys a product. The product's got a name. You can see that graph. It's very, very simple. Okay? So how do you take that and then immediately build a model? So, and again, what I'm a big believer in this enterprise graph thing is if you can't show insight to somebody really, 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 really fast, they just don't believe you. And they're not going to invest in the technology. So that's the key thing, is how do you get to that insight? And it may just want to be one single point of insight, but you need to get to that insight very, very fast. So at FactGem, what we've done is created Whiteboard. And so this is a little animation showing you how you can very quickly, you just type it, it's totally unstructured as you're building the schema. Actually, I'll have Clark tell you exactly what's going on here.
Right, so again, you're able to just go in and describe your business model. You start typing it in. We generate the nodes for you. We even give you some cool icons you can choose from and stuff. And so you just describe your business model, right? Again, just like you're whiteboarding it. And so you're adding different node types, right? And obviously these all become neo nodes under the covers, and the types become labels. And then you can just go ahead now and start drawing those relationships, right? So my associate has a transaction has an associate, and my customer makes a transaction. You won't see in this demo here, but we also even allow you to enforce some rules on that relationship. So for example, that only one transaction can only ever be attached maybe to one customer. So you can enforce that. You can take these models to and you can version control them. People talk all the time and say, our schema is great, the graph's great, but we have a model and it has to evolve with the business, and sometimes we change something and then we don't know what we changed, we need to go back. Well, you can take this and you can export it and you can put it in version control. So you can know how you progress your model. Like we always use in relational databases, right? You need to have that understanding. So again, here now, we've created relationships, now you see them all laid out, now you can add properties on them. You can set data types on them. You can choose whether or not they're indexed. If you want to get really fancy with it. But again, really, it's very, very simple. A business analyst can do this. A business analyst probably should be the one in the company doing this, right? Someone who really understands the actual business. You don't have to be an engineer to do this. You probably shouldn't be an engineer. Again, it's people who understand your business. You're making this technology really accessible to those business experts. In a way it's never been possible before, and they let them build their own graph.
So the key thing here is what I have found is that when you show that, then you go, okay, great. Well, now I got to clean my data, I got to upload my data and all that kind of stuff. And so what the team built was what they call as Uploader. So what you're able to do is literally in real time, take this as an example, taking in some CSV files. But what it allows you to do is when you build the Uploader, you create the identity match. And so when the data is uploaded, it picks which nodes it's going to connect to. So you're actually building a fully queryable graph database in this amount of time. And the thing that I think is really interesting about this, if you think about technology, databases are kind of the, yes, sir.
It seems to me what you're showing is essentially this half-and-half scenario. Because when you talk about 900 people and thousands of tables, there's essential problems with data governance. Like, what's the customer? Oh, is the customer everybody who signed a contract? Is the customer everybody who's using the product? Is the customer everybody who's reached out to marketing-wise? And, I mean, this 2-hour scenario is all well and good.
Right.
And I think the technology you're talking about is quite powerful and interesting. But there's a whole data governance layer that has to be there in order for you to get the insights that are actually going to drive the quality, not just connecting everything that was named uniquely in the same way. So how does a data governance layer, fit on this? Because without it, I don't think, without it, you're making a lot of assumptions in your favor.
Yeah, so let me, I'll answer part of it, you can answer the tech part of it. So what we're describing here is the ability to get to an insight very quickly, so then the corporation goes, wow, that's kind of cool. Then they take the next step. This is not a final product. I mean, it can be a final product if you want it to be. But what we have found is this then goes into a fully RESTful API, and you can do a lot of this other stuff. But the key thing here is, I think in order to get adoption of the graph, is you've got to get to that insight very, very fast. So I'll let Clark answer the key questions on governance.
No, I mean, you're totally right. I mean, we're absolutely not saying there's a magic bullet. There's data governance problems, there's information architecture problems, there's data cleansing problems, and so on. Those don't go away just because you use a graph or because you use our tech. Absolutely not. Right? Doing a real scale enterprise application is hard. And yes, you have to have people understand that. You have to go through that process. What we're saying again at Marcia is get to the insight, let them see the power of the graph, so you can start addressing those, and then do it iteratively, right? And the great thing too with this is start with a small, understandable chunk of the business, right? That maybe has some value ideally. Model that, get the application going, get some insight. Start having the data governance conversations, right? Figure out what the rules and the policies should be, get some models, version control them, take the next step. You can modify it, because again, Neo doesn't enforce a schema on you, it means we can update our schema in real time while it's running it with data in it, and you can add stuff, or you can move things around.
Actually, one of my favorite stories was one customer. We went through that whole process, and they were about ready to present to the CEO, and we had a 4 o'clock meeting. And at 10 a.m., she said, "Holy criminy, how I identified store profitability was totally wrong. I didn't have the right data. I did it all. It's wrong." So we said, "Well, let's just do this. How about you just send us the new data, show us how it fits into the model, we'll connect it in, and we'll still make the meeting at 4 p.m. So we did, by the way. And so that's the whole point, is you want flexibility, because you're right, the real world, you need to be able to try this stuff in real time. You need to be able to make mistakes. You need to be able to have versioning. You need to be able to do all of those things. Because in enterprise, it's a constantly changing thing. And like you said, a customer to one person is not to another person. And so that's one of the things in Uploader, we actually allow people to actually do, they're doing ETL, they don't even know they're doing ETL, which is kind of fun.
Right.
Yes?
You spoke about the thin layer of schema that we have in your slide there, talking about which showed us a parallel approach. So you're keeping the features in one the groundwork for you around, as you also pointed out, these entities and relationships can evolve, schema can evolve over time. So do you have the ability to kind of introspect and kind of do data discovery or discovery of databases stuff? As things change, the automatically know it doesn't have to be committed, the admin kind of goes and knows what's happening. And I think it's something about data.
Right, so just to repeat the question. Yeah, I think basically, so your question boiled down to was, we showed about how you can pull data from different data sources in a kind of federated manner, with your term, to pull them in and manage the schema and so forth. The question was, do we have an out-of-the-box tool that lets you sort of reach out to the other data sources so you can detect changes and so forth? Right now, we don't. Honestly, right now, that's something we're looking at. To that, the other gentleman's point as well too, as soon as you get into a big enterprise, you say, I want to reach out and touch your existing databases. People get a little nervous, right? People get a little nervous about giving away keys to the database, especially if there's compliance and auditing and stuff. So most of our customers tend to push changes. So we engage in a long conversation with them about enterprise data management and so on, and then it sort of happens that way. So that's a direct connect or something we're evaluating right now, but is not in place at the moment. Yeah, sure. Yeah.
How does the versioning manifest itself in the tool? Is it just a moral record and it shows up, or is it because whether it's schema or actual object, for instance, it's kind of
So we don't directly version it here. We believe they're good that Git, CBS or SVN, whatever that is probably a much better version tool than anything we're going to build. You can save off different versions here. So a lot of times in projects, we do a format versioning where we'll save the schema name and we'll put a date on the end of it, and then we'll do a new one and change the date, which is not necessarily a best practice, but it's easy. But you can export it, again, basically as a file. And my recommendation is actually put it into like an actual source control system and really version it, if that's an issue. The schema, so the schema stuff, right, so, as your schema evolves, as you add new relationships, as you add new rules about the relationships of properties, you can go back and see what's actually happened with it, right? I mean, yes, you could version the whole graph database, but that's kind of big.
So then the last but not least is you want to be able to actually see, visualize what's going on. And so what we have found is the ability to actually do that in real time and have a whole bunch of basically dashboard widgets for graphs and lists, and you can see things in a web view or a map view that does full geolocation, things like that, is very, very important. But I think the key element that I think you got to say here is graph is new. People don't fully understand it. So you have to get, just to repeat ourselves 1,000 times here, you have to get to insight quickly. And you have to see it. Because once you get that, then you can actually implement a bigger system. And so what Clark and the team have done is basically built a RESTful API that allows you to then build any custom application you want on top of it. So once you get an application, and I would say this on any kind of implementation that you would be doing for an enterprise data fabric, is, as Clark said, start small, start with something that you can get your hands around with, and then show them that insight as quickly as possible, and then build the application on top of it. This is an example of a custom app that was built. But the way I look at it is, I think this is the architecture of the future. I think all existing applications are going to be basically data services. Imagine, it's just kind of like, that's how web is done today, right? You got Google Analytics, you got a LinkedIn connector, you got this connector, that connector. Imagine all your legacy databases as just service providers, data service providers. You could also have an enterprise data warehouse, you could have some Hadoop data lake stuff. You put it into the fabric, and out of the fabric, you then go create apps. So you create, in this case, we've created 3 apps so far. We've created a brand and what we call Customer 360 app. We've created a fraud detection app. We've created a supply chain app. The supply chain app is really exciting. And then there's other apps you can create on top of that data.
Right. And I think this is crucial. This concept of turning your existing legacy databases into data services. So I've been in the database world and trying to sell different database forms, not as long as Mark, but for a while. And kind of the quickest way to hit an immediate roadblock is to go to somebody and explain to them why you're going to get rid of that database. It sounds like a great idea at first, right? You're going to save money, you're going to turn this other thing off, and it's going to be great, and next thing you know, you're on the curve. Nobody wants to hear that, right? They've invested a lot of money in that tech, particularly in certain areas, finance and healthcare and so on. There's a lot of regulation, and you want to now tell them, hey, I know that if you screw this up, the federal government's going to come and audit you and maybe put your CEO in jail. But trust me, we're going to move all of that stuff out of that and put it into a graph. It's going to be fine. No way. I don't even want to do that, right? I don't want to be that guy either. Let them keep their investment. Make their existing investments more valuable. The existing databases can stay the data source of record. Who cares, right? There the auditing can live. The compliance can live. Nobody has to go to jail. But now through the fabric, right, you can give them value they couldn't before, right? And you don't get that resistance of, oh, I'm going to throw away my stuff. So, sorry, yeah.
So the notion of putting this metadata layer.
It's not metadata, it's the actual data. It's the actual physical data.
Right.
What's that?
You're pulling data from the respective source into the graph itself.
Yes. It's actually holding, like, the whole concept of using a graph for metadata and keeping the rest of my SQL database, I think it's a total fallacy. Because at the end of the day, you want to query the actual data. If you want to do, for example, for a retailer, if you want to do basket analysis, he or she buys this product, what are the 3 other products they most likely buy with it? You have to have the raw data. You can't have the metadata. That's not going to help you. And so the whole idea of the data fabric, and this is what I think this is where it's going to go, is that once you do this, and you start running your business in this enterprise data fabric, over time, you don't need any more of these applications. You can start, sunsetting some of these other applications.
So follow on, what percentage of the data winds up being
if you don't need it, you upload whatever you need. You know, do you need the fact that that person has a dog? I don't know. I mean, if it's a column because one day you thought that person, you know, you wanted to know all your customers who had dogs, but they.
Your experience, what percentage?
I'd say our experience would be 30, 40%.
Yeah, about that.
About that. I mean, think about it. The way I look at it is, you're a business analyst. What are the queries they're asking for all the time? Okay, so actually sit down with all your business analysts in the corporation and say, okay, what's the common query? What's the common things you're doing? And that basically will take care of 80% of what you're doing.
And since involved in that, one of the interesting things we see, because I thought it would be much higher. And what we're discovering is there's, as you pull stuff out of VDW or Teradata or whatever their data mart might be, there's so much data that exists there right now, either because they can't join it, so they have to materialize in all these different data stores because they can't join it, or they can't run interesting calculations off of it in real time, so they have to run them, you know, in some other system you had, and it runs for 6 days, and they go back and they say, oh, these are all my customers that are new to the brand. Well, I can do that in less than a second by DataFabric, so I don't need those copies. So you see that a lot.
That's actually a good point. What you see in a lot of these data stores is they're basically copying data from other parts of it so they can do the calculations that that piece of data store is asked to do. So we actually, I think over time, you actually see a reduction of the actual amount of data you have out there. Yeah?
But aren't you bound by how much data you can bring into the engine? And I mean,
We have, yeah.
I mean, it seems like there's models like, you know, the Reltio thing with the metadata graph and then Cassandra underneath that allow you to do aggregates on really large scale data that's still in a scale out architecture or common scale out architecture that doesn't, you know, require you to bring it all. And then also the maturity of the analysis tools, you know, that are working on other platforms are pretty strong. And also, and I think you're exaggerating, you're not death of SQL. I mean, you know,
No, we're not saying there's no depth of SQL. We're just saying there's a, I think the problem with the SQL layer for BI, you want to do more than 3 joins.
yeah, but I mean, SQL now is completely machine generated. If you look at something like, if you look at the SQL that Looker generates, it's just great, you know, and it all works because it's all tuned to the engine. So I mean, then there's plenty more joins. There's as many joins as you want. I mean, so I guess I'm a little suspicious of this idea. Once you get it in the graph, you can do any query you want. I think there's a bunch of queries. There's a personality that this is going to work for. A personality of application of analysis.
Oh, sorry, that's why you're here.
What do you mean? I mean, you just said at the
Sorry.
beginning. You said at the beginning, I want to be challenged.
Right, no, and I do want to be challenged.
No, it's good. So we just, and so here's another question too, and I got one eye on the clock. So quickly to address some of those, you know, is there a limit, Tom? Maybe, I don't know. But again, you know, IBM now, if you want it, and you can afford it, you can get what was it, 40 terabytes of RAM. What a pretty big database with 40 terabytes of RAM. If you got more than that, I guess you win. I don't know. But I worked a lot in Intel, and I've certainly seen bigger databases than that you. But not to say as well, but even there, that's a lot of data. Well, not the biggest, but it's a lot. Yeah, SQL, no, not that. Is Graph right for everything? No. If I want to build a system that just, you know, ships, you know, if I want to just build a system maybe that just does like ERP, and I want to have orders and ship orders, I don't need a graph. I can run it really fast in SQL. And can you write lots? Are there really cool things that make really crazy SQL out there? Sure. And can you do 12 joins? Absolutely. The customer working now, they would run those queries. 12, 14 joins. Took about 6 days. If you got 6 days, go for it. I'm not saying it can't be done. I'm saying it doesn't make sense all the time.
Now we have, for example, we have one thing they did on a regular basis. It took them 18 hours to run the joins. And they were using Looker and some of those other tools. You're absolutely right. In the graph, once we have all the data in the graph, that exact same query takes 3 to 4 minutes.
Well, I think the important thing you've got here is getting people to turn the light bulb in about how interact.
Yes.
I think that's the real news to me. How do you, that's the bounding condition for Neo4j in all the graph growth.
Absolutely.
Getting application architecture to understand what it can do.
Yep.
And how it can.
Exactly.
Let's get a couple other questions. Yeah.
We need to elaborate on the point just made here. When you're talking about legacy systems and existing enterprise systems, but for new product development, I think one of the questions can a traditional RDBMS well use? What capabilities graph database? I totally get how
Yep.
a fabric like this would work in that case. I think the challenge from an architecture and a development point of view is understanding where that line is and what architecture best supports it.
So the rule of thumb I would do, and I think Clark just said this, is I literally, if I'm developing a new application, I get up on a whiteboard and I basically just draw my data architecture. You know, person lives at an address, person shops at a store, that store has product, and then ask myself what questions I want to answer that. If I have applications where I want to go more than 4 or 5 degrees type questions, give me all the people that live in this city that are from the age between 20 and 30 and bought this product and use this promotion, whatever. I'm just making something up. Then graph is perfect. But if you have things that are very columnar and very kind of just pure transactionally oriented and compute oriented, absolutely a SQL is the best way to do it. I mean, yeah.
I'm sorry, but in determining what I would imagine whether or not there needs to be a blend, I want to make sure I understand
Yeah.
your answer correctly, which is that you are starting no bits, just with the white.
So I'll give you an example.
Your feeling would be that in answering those questions, that the Neo4j graph model is a sufficient source of records as well.
Absolutely. And so I'll give you just two, and then we got to answer this guy's question. So for example, the other issue you're going to have is your programming talent. Your programming talent is going to be very happy with Postgres and whatever they happen to do. So at Drive, we've actually built our own kind of information management system. It'd be perfect for Graph. But our 2 programmers don't know Graph. So I actually sat down with them last week and I said, okay, show me your SQL framework. It's 20 different tables with about 14 different join tables. 20 different data tables with about 14 different join tables. And then I sat down on a whiteboard and, we should use Graph for this. Well, we had to go very fast and we didn't know Neo. Okay? And so going back to whoever's question was over there, that's what we're trying to do, is get people up to speed as quickly as possible to open up their mind that you can actually do this in Graph. And that's what you have to ask yourself in the question as you build the company. Yeah, one last question. Okay, a little bit more time. Another question.
Yeah, well, I just wanted to kind of build off some of the points. So I think when you nailed on exactly what I've observed at Enterprise as well, and I think you're all both right in it. The enterprise systems that are there are not going to get replaced. They serve as a service, but they describe things in the language.
Sir, can you go the other way, please? Yes, not.
Yeah. That's between interdepartmental.
And the organization thinks of the way it represents the business. 80% of people who work for elsewhere in the
Yep.
organization have a different way of thinking involved in the business. That's well, I've never met it.
Absolutely. Well, we're all wrapping up. I hope this was helpful. Please ask us any questions. We've got a booth out there, and we can take it from there. Thank you very much.